everybody. Happy snow day. Unfortunately, I'm still giving you work to do because we need to talk about arithmetic sequences before I leave on Friday for Orlando. So to keep us on track, we need to go through this lesson, and hopefully that you are going to actually do this. Arithmetic sequences, remember, that is where we add the same number repeatedly to get the next term. Most of you figured that out when we were doing the little cards in our textbook. Examples like 4, 8, 12, 16. Most of you at this point have written that that sequence would be just adding 4. Now we're going to go to the correct terminology and say that the common difference is 4, in which case we are actually not going to write common difference is 4. We are going to say D equals 4. When we write D equals 4, that tells us also that we know that we have an arithmetic sequence because we use a different notation for our geometric sequences. Another example of an arithmetic sequence: 9, 6, 3, 0, -3. Most of you at this point have just said that you are subtracting 3. Subtraction is not allowed in arithmetic sequences. We say that the common difference is -3. That negative takes care of our subtraction. And we say that D equals -3. Again, that D tells us that we know we have an arithmetic sequence. And just a little side note, that is how we show that a sequence is subtracting, is by using that negative. A non-example of an arithmetic sequence: 1, 2, 4, 7, and 11. I'd like you to pause the video and answer the question, why do you think this is not arithmetic? Okay, this is not arithmetic because the sequence is adding 1, 2, 3, 4. We called that in class adding consecutive integers. It is not adding the same number every time, so it does not fall into our arithmetic sequence category. All right, some practice problems here. For each sequence, determine if it is an arithmetic sequence, and if it is, identify the common difference. I'm giving you the sequence 1/2, 1, 3/2, and 2. So we notice that if we add a half each time, remember that 3/2 is actually 1 and a half. And if we add another half, we do get 2. So this is arithmetic, and the common difference is a half. And that's all we need to write. Next sequence is 55.5, 52.75, 50, and 47.25. You know, decimals are kind of tricky. We have to pull out our calculator sometimes to do these. But this is going down, so we're hoping that it's subtraction by a common decimal. And our common difference in this case is negative because we're subtracting 2.75. And what about 25, 34, 45, 58? Pause the video and answer the questions. Okay, this is not arithmetic because they are not adding the same value every time. A little bit of vocabulary and notation for us to continue with this lesson. A sub n is just the value of any term that you want. So if I want the 5th term of a sequence, I would say A sub 5. If I want the 10th term, I would say A sub 10. A is just simply a notation. It's not a variable or anything like that. N represents the term number. A sub n minus 1 is the previous term. So I'm giving you here an example of 25, 34, 45, 58. If I'm looking at just the term 34, the n is 2 because it's the second value of the sequence. So a sub 2 equals 34. And then a sub n minus 1, the term before the second term, so the first term, is 25. You can think about the a sub n and the n. The term number is like the seat number. If you were to go to a concert and you're in seat number 53, you are not 53, but the seat number is 53. You are the term. So, for example, Julia would be the term in seat number 10. Julia is the person that's in it. So the seat number is 2, and what is in that seat? 34. All right, so the main piece of this lesson is these 3 different ways to write our sequence. So I'm giving you the example of 3, 7, 11, 15, and 19. The recursive formula is what you've been used to doing. You take the 19, you figure out, oh, we're adding 4 every time. So you would take 19, you'd add 4, and you would get the next value of the sequence. Then you would add 4 again and get the term after that. So the recursive formula you're used to using is just we're not used to writing an actual formula for it. So in the recursive formula, hang on one second, sorry. In the recursive formula, we simply use a brace. We state what the first term is, which in this sequence is 3. And then this is really all we have to write. We say a sub n equals a sub n minus 1, and then we're adding 4 to it because that was the common difference. There's nothing else for you to substitute in. That's really all that you write. And both of these pieces make up the formula. You cannot leave off either of those pieces if you expect to get full credit on your assessment. Now the explicit formula might be something that's a little bit different for you. The explicit formula says that any value of the term equals the first term plus or minus, in some cases if you are subtracting, the common difference times the quantity n minus 1. So in this case, a sub 1 is 3. The common difference we already figured out was 4. And then we're just going to multiply that by n minus 1. Sorry, don't want you to see the other examples yet. Okay, so here's your first term, the common difference times n minus 1. And you can leave it like this. You don't have to multiply it out. Where we multiply it out is in the function form. And simply, you take it, use the distributive property, combine your like terms, and you write a linear function. Notice I said linear. All arithmetic sequences are linear functions. So now I'm going to work the next example out with you step by step. We have example number 2 is 12, 5, negative 2, negative 9. So first we have to figure out whether or not this is arithmetic, which it is. Our common difference is negative 7 because we're subtracting 7. So the recursive formula simply says that I have to state what the first term is, which is 12. And then to get any other term of the sequence, I take the term before it and subtract 7. And then put my brace on it so to show that they go together. The explicit formula, to get any term of the sequence, it's my first term plus or minus the common difference. In this case, we have to use subtract because we were subtracting, times n minus 1. And for that, you're done. Then the function, make sure you use function notation. Distribute it out. Combine like terms. 12 and 7 is 19 minus 7n. Of course, if you write this as f of n equals negative 7n plus 19, that is correct as well. Next example, negative 100, negative 50, 0, and 50. We do have an arithmetic sequence with a common difference of 50. So the recursive formula, and you do need to know both formulas for your assessment. First term is negative 100. And to get any other term of the sequence, we simply take the term before it and add 50. Explicit formula. Any term is the first term plus 50 times n minus 1, and then the function f of n equals negative 100 plus 50n minus 50. And then personally, I do like my variable to be first, so it is in slope-intercept form. So 50n minus 150 is my function. Okay, last example on this page. 7, 9, 11, 13 has a common difference of 2. Recursive, first term is 7. Any other term is the term before it plus 2. Explicit, any term is the first term plus 2 times n minus 1, and then the function f of n equals 7 plus 2n minus 2. So my function is 2n plus 5. At this point, I'm going to give you some practice problems. Please copy these onto your page, pause the video, work them out, give me the recursive formula, the explicit formula, and the function. So go ahead and pause the video and work on practice problem number 1. Okay, check your answers on number 1. You can pause the video again if you need to. And here is example number 2. Again, work this out. Give me all 3 parts, the recursive, the explicit, and the function. And then check your work on this problem. Okay, here are your answers for practice problem number 2. And of course, if you have any questions on any of this, please email me. I will be checking my email throughout the day, kuzielcj@vvsd.org. Now, for your assignment, if you have your textbook at home, if you happened to bring it home with you over Thanksgiving break, I need you to go through the sequences that we worked on in class on Tuesday before break. They were those little rectangles. There were like 6 or 8 to a page. I think there were like 16 of them. I want you to find all the sequences that are just arithmetic. So you're looking for all of the sequences that you were either adding or subtracting. I want you to label them as arithmetic. So after your sequence and you've described the pattern, so like most of you for subtraction problems would like, this really isn't letter A, so I just use this as an example. So let's say you said that this was subtract 17. You're going to write that this is arithmetic. And again, this is not the answer for card A. You're going to write that it's an arithmetic sequence and that the common difference is now correctly written as negative 17. And that's it for today. And I will see you guys hopefully tomorrow. if we don't get any more snow. And we will continue with our geometric sequences. Have a great day.